Welcome dear students to the class of mathematics. Last session we started with chapter number 13, surface areas and volumes. A homework was given to you and I am sure you all are ready with the homework. I hope you all must have learned and by hearted the formulas of surface areas and volumes of solid figures. This is very important because when we are solving the sums, the formula should quickly come in your mind. So here we go. Let's begin with exercise 13.1 of your textbook. As I told you, the sums in exercise 13.1 are based on combination of solid figures. So let's go one by one. Let's begin with the first sum of exercise 13.1. I'll read the sum for you. Two cubes, each of volume 64 centimeter cube, are joined end to end. Find the surface area of the resulting cuboid. Children, before we start solving this sum, I'll appreciate if all of you will have a pencil and a book along with you so that when I'll be explaining you the sum, you will try to do the calculation part. And as I read the sum, please try to draw the rough figure also if you can. So just see here, two cubes and the volume of the cubes are given, each of volume 64 centimeter cube. So volume of one cube is equal to 64 centimeter cube. Now you know the formula, volume of a cube. What is that? Side cube is equal to volume of a cube. Substitute. Now volume is given to us. Let A be the side. Okay, we'll consider A as the side of the cube. So A cube is equal to 64. So A is cube root of 64 and cube root of 64 is 4. So A is equal to 4 centimeter. So look at the figure. This is 4 centimeter. This is also 4 centimeter. Now the sum says that when you joined both the cubes end to end. So look at this part of the figure. If you join both the cubes together, it forms a cuboid. So now from the measurements which we have calculated as side of the cube as 4, what we'll get? The length of the cuboid. This is 4, this is 4, so total is 8 centimeter. Length is 8 centimeter. Breadth, this part, that's 4 centimeter. And height of the cuboid is equal to 4 centimeter. So we have all the measurements, length of the cuboid, breadth of the cuboid and height of the cuboid. What is asked? Find the surface area of resulting cuboid. Is the formula clicking in your mind? If yes, then quickly jot down. So area of cuboid is equal to 2 in the bracket LB plus BH plus HL. You have all the three things with you. You have L, you have B, you have H. Substitute the values. So 2 outside the bracket. In the bracket, 8 into 4 plus 4 into 4 plus 4 into 8. Do the calculation. 2 in the bracket, 32 plus 16 plus 32. Now if you add these three figures, we get 2 in the bracket 80. So 80 into 2 is equal to 160. So the area of cuboid is equal to 160 centimeter square. Right children? So let's move to the next sum. So question number 2 from exercise 13.1, and the sum is a vessel is in the form of a hollow hemisphere mounted on a hollow cylinder. Look at this. First just bring in mind which two figures they're talking about. A vessel in the form of a hollow hemisphere. So your first figure is hemisphere. And mounted by a hollow cylinder. Meaning is that the hemisphere, and on the hemisphere the cylinder is mounted. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. So quickly children, the first thing which we will do is to draw the figure by reading the sum. Right, as I said, there are two figures given here. One is hemisphere and one is the cylinder. So this is a hemisphere which is drawn and it is mounted. A cylinder is mounted on the hemisphere. We are given that the diameter of the hemisphere is 14. So you look here, this is the diameter which is 14 and the total height of the vessel. Total height is including the cylinder and the hemisphere, and the total height is 13 centimeter like this. Now what we have to find out? We have to find the inner surface area of the vessel. So the inner surface area, if you imagine, it is the curved surface area of the cylinder and the curved surface area of the hemisphere. And if we add both the areas, we will get the inner surface area of the vessel. So let's go one by one. Let's begin with the hemisphere first. So we have to find out curved surface area of the hemisphere. Now what we have with the hemisphere? We have the diameter of the hemisphere, that's 14 centimeter. Therefore radius of the hemisphere is equal to 14 upon 2 and that is 7 centimeter. So we have the radius of the hemisphere. Now what is the formula for curved surface area of a hemisphere? The formula is 2 pi r square. Now you know the value of r. Substitute it. We get 2 into 22 by 7 into 7 square, because 7 is the radius of the hemisphere. So 2 into 22 by 7 into 7 into 7. So 1 7 you can cancel and you are left with 2 into 22 into 7, and that comes equal to 308 centimeter square. So we have calculated the curved surface area of the hemisphere, and that is 308 centimeter square. Now what is remaining? Now the cylindrical part is remaining. What do we have for cylinder? We are having the total height and the radius of the hemisphere and the radius of the cylinder will be same. So let's check out now the other part. So we have to find out curved surface area of cylinder, and the formula for curved surface area of cylinder is 2 pi RH. Children, I hope that the formulas are striking in your mind and you are able to recollect that. If it is still not coming, then what you have to do, you have to again start revising the formulas. Yeah. So see here, radius of the cylinder is equal to radius of the hemisphere, right? And that is equal to 7 centimeter. So this is the radius of the hemisphere and this is the radius of the cylinder. Both are same, which is equal to 7 centimeter. Now we should know the height of the cylinder because it's there in the formula. How will you find out the height of the cylinder? So height of the cylinder is equal to total height minus the radius of the hemisphere, because this part is the radius of the hemisphere and we are aware of that. It is 7 centimeter. So what we get? 13, that's the total height, minus 7, that's the radius of the hemisphere, and what we get is 6 centimeter. Therefore, height of the cylinder is 6 centimeter. Now we just have to substitute the values into the formula. So curved surface area of cylinder is equal to 2 pi RH. Substitute the values. 2 into 22 by 7 into 7, that's the radius, and into height, which we have just calculated, which is 6. Now this 7 you can cancel, so we are left with 2 into 22 into 6. Multiply quickly, your answer is 264 centimeters square. Right? So we have calculated curved surface area of cylinder. We have also calculated curved surface area of hemisphere. And if we add both the areas, we will get the inner surface area of the vessel. So add it now. We have 308 plus 264 centimeters square, and if you add it, the addition comes to 572 centimeters square. Therefore, the inner surface area of the vessel is equal to 572 centimeters square. Right, children? So not very difficult. Only thing is that you should be able to visualize the figure which is mentioned in the sum. One thing I want to mention again, that the value of pi, you should always take 22 by 7 unless and until they specify the value as 3.14. If they specify, then only 3.14. Otherwise, you have to consider value of pi as 22 by 7. Okay? Right. So here comes the third sum, exercise 13.1, question number 3. A toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. Now first, just find out which two solid figures they are talking about. They are talking about a cone and a hemisphere. A toy which is in the form of a cone is mounted on a hemisphere. So the cone mounted on a hemisphere, it's like this. Then the total height of the toy is 15.5 centimeter. Find the total surface area of the toy. Easy to find out, not very difficult. I think some children might have visualized the figure and the formula in mind, but let's jot that down on the paper so that you can come to the answer. Look at that. First we will try to make the figure. A cone, it is mounted on a hemisphere like this. You are given that the radius of the cone is 3.5. So this is the radius of the cone. And the hemisphere has the same radius. So both radius of a cone and the radius of the hemisphere is 3.5 centimeter. We are given that the total height of the toy is 15.5 centimeter. So this is what is the total height. That is equal to 15.5 centimeter, right? Find the total surface area of the toy. Now I can just make out that when I have to find out total surface area of this combined figure, it is curved surface area of hemisphere plus curved surface area of a cone. So let's find out area one by one. Let's first find out curved surface area of the hemisphere. And what is given to us? We are given that the radius is 3.5 centimeter and the formula for curved surface area of the hemisphere is 2 pi r square, right? Substitute the values. 2 into 22 by 7 into 3.5 the whole square. So you will be writing 2 into 22 by 7 into 3.5 into 3.5. Cancel this 3.5 with 7. So 7 into, here it is 0.5 into 3.5. Now you have to do this calculation. You have to be very quick in doing that. 2 into 22 into 5, 0.5 into 3.5, and the multiplication comes equal to 77 centimeters squared. So the curved surface area of the hemisphere is equal to 77 centimeters square. Now let's find out the other part of the sum. We have to find out curved surface area of the cone. Look at this figure. This is the cone and we are given that the radius of the cone is 3.5 centimeter. And when we are calculating curved surface area of the cone, its formula is pi r into L. And I told you that L is the slant height. It is this height which is not given to us. So we'll have to first find out slant height, but for that we should know what is the height of the cone. And height of the cone is not given to us. We are given the total height of the toy. So I can find out height of the cone. Height of the cone is equal to total height of the toy minus the radius of the hemisphere. Right? So 15.5, that's the total height, minus 3.5, which is the radius, and that comes equal to 12 centimeter. So height of the cylinder is 12 centimeter. So for finding slant height, I'll make use of the Pythagoras theorem, and according to Pythagoras theorem, L square is equal to h square plus r square. Substitute the values. We have h as 12, so L square is equal to 12 square plus radius is 3.5, its square. Okay, this 3.5 we will convert into fraction so that it will be easy for us. So 3.5 you can write 35 by 10, and 35 by 10 comes equal to 7 upon 2. So L square is equal to 12 square plus 7 upon 2 the whole square. 12 square is 144 plus 49 upon 4. Now to find out this value, we'll make use of the cross multiplication. So 144 into 4 plus 49 upon 4. Right? That comes equal to 576 plus 49 upon 4. And 576 plus 49 is equal to 625 and upon 4. So L square is equal to 625 upon 4. So L is equal to square root of 625 upon 4. Square root of 625 is 25 and square root of 4 is 2. So you get L is equal to 25 upon 2. Reduce it to lower terms and we get 12.5 centimeter. So slant height of the cone is 12.5 centimeter. Now we have slant height, we have radius of the cone, so we can find out curved surface area. So curved surface area of the cone is equal to pi into r into L, 22 by 7 into 3.5 into 12.5. So cancel this 3.5 with 7, that's when you cancel it, you get 22 into 0.5 into 12.5. And again there is a calculation, so you have to be very precise and correct when you are doing the calculation part, and your answer comes equal to 137.5 centimeter square. And this is curved surface area of the cone. So we have calculated curved surface area of hemisphere, we have calculated curved surface area of the cone, and when we add both the areas, we will get the total surface area of the toy. So total surface area of the toy is equal to curved surface area of hemisphere plus curved surface area of cone, and that is 77 plus 137.5, and when you add it you get 214.5 centimeter square. So the total surface area of the toy is equal to 214.5 centimeter square. Right, children? So I hope it's easy. Now the thing is that you should have patience to solve, go ahead, do stepwise so that you will not go wrong. Otherwise when you read the sum, it's not difficult. You should be able to just visualize the figure. Once the figure is ready on the book, solving is not difficult. Alright? So we will stop for today. In the next period, we will continue with the remaining sum. Till then, bye and take care.